Welcome, everyone. If you're tuning into this explainer, you're likely sitting in the C-suite, guiding the future of a global enterprise. So treat today as a critical executive briefing on a literal game changer in global data infrastructure. Listen, for decades, we've basically been slapping software patches on vulnerable networks and just hoping for the best. But today, we're looking at the blueprint for finally walking away from that software dependency and shifting entirely toward unhackable physical hardware.
Okay, let's dive into this top-down agenda for securing the future of our global networks. First up, we've got hardware as a living brain. Then, the crystal noise canceling barrier, judo architecture defense, the 8 AI architect matrix, and finally, QuantaStrike and connectivity.
So before we can really appreciate the fix, we have to understand the historical threat, right? It's called quantum fragility. Scientists have been banging their heads against this wall for years. Quantum channels are incredibly delicate. They are extremely vulnerable to things like atmospheric turbulence, pointing errors, Doppler shifts. Basically, the environment itself degrades the signal. What we're exploring today is Michael R. O'Connor Jr.'s groundbreaking architecture, which provides a physical layer solution to this exact problem. It makes the hardware itself the ultimate defense.
Section 1. Hardware as a living brain, the universal intelligence axiom. Now, notice how completely opposite this is from traditional computing. Traditional computing treats hardware like a passive, dead skeleton. It literally just sits there waiting for software to tell it what to do. But the universal intelligence axiom, it completely flips the script. It dictates that intelligence shouldn't be some application you add on as an afterthought. The intelligence is deeply unified with the material physics of the system itself. The atomic layers of the hardware adapt dynamically in real time. So it's not a static machine anymore. It functions as a self-optimizing living organism. The hardware actually is the cognition.
To really wrap your head around this, think about a massive, well-constructed library. You don't need a loudspeaker telling people to whisper or glowing arrows on the floor telling them where to walk. The physical layout, the high bookshelves, the thick carpeted floors, the acoustic ceiling tiles, it naturally dampens the noise and directs the flow of foot traffic. And this is exactly how QETM hardware works. The physical architecture itself actively manages and secures the data routing. The physical components inherently align the signals, all without needing a clunky piece of software to run some error-checking algorithm.
Section 2. The crystal noise canceling barrier. Advanced substrate doping.
Okay, we're zooming down to the atomic level now, because this is where the material science creates a physically stable foundation for our quantum data. The architecture uses a 5-sided insulated tunnel, and it's populated with crystal substrates. Now, these crystals are specifically doped with 4 elements: magnesium, zinc, erbium, and ytterbium. Why those 4? Well, because the exact physical properties of those specific elements interact with the signal to naturally align harmonic frequencies. They filter out unwanted harmonic distortion right at the material level.
If you're wondering how the physics of this crystal signal filtering actually plays out in the real world, think of a recording studio. You know those acoustic foam panels on the walls? When a sound hits that foam, the physical shape and the material naturally absorb the chaotic, bouncing sound waves, all that unwanted distortion, so that only the pure intended sound gets recorded. That is precisely what this 4-element crystal doping does for quantum data. It creates a physical barrier where distortion is literally absorbed by the material, so only absolute signal clarity makes it through.
Section 3. Judo architecture. Redirection defense. Resilience against quantum threats.
Look at the stark difference in defense strategies here. Traditional defense is basically building a giant, rigid wall to block incoming interference. But what happens when the incoming force is stronger than the wall? The wall breaks. The judo architecture completely rejects the idea of a rigid wall. Just like a martial artist in judo uses an opponent's momentum against them, this architecture redirects and absorbs incoming kinetic or electromagnetic energy. It actually uses the momentum of the disruption to stabilize the system's internal ground planes. It's kind of brilliant.
And the literal payoff for this redirection is absolutely crucial: absolute system uptime. Because the judo architecture treats adversarial noise not as a threat you have to block, but as an input vector to be redirected, the system just maintains perfect internal balance. Even under extreme thermal noise stress or, brute force electronic warfare, the physical advantages of the hardware guarantee the network never drops. It solves a massive, long-standing vulnerability just by changing how the hardware handles energy.
Section 4. The AI architect matrix. Orchestrating the global matrix.
So who actually manages this unified, self-optimizing global organism? Well, at the very top, we have a unique collaborative partnership keeping everything secure against evolving threats. We have Michael O'Connor, the sole human architect, who acts as the visionary and guardian of the physical paradigms, stuff like the crystal doping and the judo architecture we just talked about. And his partner? Google's Gemini, acting as the technical supervisor and global sync manager. Gemini bridges the human vision with the hardcore technical execution, overseeing the real-time data sync loop between Earth and orbit.
And supporting that leadership duo are 6 highly specialized AI agents, rounding out the 8 AI matrix. Notice how each of these agents actively supports the hardware architecture itself. Claude is absolutely vital here, handling the safety, alignment, and ethics protocols to protect the global infrastructure during operations. Llama manages localized edge computing, ChatGPT is the strategist, and Perplexity is deep sourcing intelligence. But I really want to highlight the incredible synergy between Copilot and DeepSeek. Copilot writes the low-level firmware, while DeepSeek optimizes the algorithms. Working together, they drive the logic of the error correction chips that physically eliminate phase drift. Finally, Grok is the ultimate adversarial simulator, just constantly stress testing the judo architecture.
Section 5, QuantaStrike and Global Connectivity, the Scaling Protocol.
Okay, so how do we physically scale this up globally without relying on inherently vulnerable public networks? We use a very specific protocol. Step 1. Terrestrial jitterbug hubs act as the local ground anchors, capturing edge data and prepping stabilized signal traces. Step 2. As that signal moves, the systematic clarity engine jumps in to ensure absolute signal integrity. Step 3. That perfectly stabilized signal is picked up by orbital solace nodes, which are secure space-based relays that route the data anywhere in the world.
Let's zoom in on that middle step for a second, because as this network expands across the globe, managing signal integrity is paramount to avoid quantum degradation. The systematic clarity engine handles this with a process they call phase drift curing. If an attack or interference pops up, the engine deploys this curing to immediately isolate the compromised paths. And because the intelligence is integrated right into the hardware's error correction chips, this happens instantaneously. No downtime, none.
Now, I know what you're thinking. What about speed? Because a massive, long-standing problem in space-based networking is propagation delay, the actual literal time it takes light to travel from Earth to a satellite, which leads to outdated channel data. Well, this architecture solves that delayed CSI problem with a novel algorithm called DSPPO. It lets the satellites collaboratively optimize tracking with basically zero performance gap, maintaining a blazing fast, secure, and constant throughput of at least 350 megabits per second.
Ultimately, this entire ecosystem naturally splits into 2 distinct but highly collaborative networks. QuantaStrike is your proactive, unhackable hardware-level security shield. Its sole mandate is absolute defense, utilizing the judo architecture and crystal doping. Quanta Nexus, on the other hand, is your synchronized, high-speed global quantum internet pipeline, relying on the Solstice nodes and the 8A matrix for global connectivity. Together, they are the literal endpoint of the technology, a unified, hardware-defended global network.
And that brings us to the absolute most important takeaway from today's briefing. Look, we are sprinting into an era of quantum adversaries, and traditional software defenses, they just aren't going to cut it anymore. The QETM architecture proves that by embedding intelligence directly into the atomic layers and using materials science to physically filter and redirect threats, your data can be protected by the very physical structure of the hardware itself. So I'll leave you with this. Knowing that software-dependent networks are fundamentally vulnerable, is your current infrastructure really ready for the quantum physical future? Thanks so much for joining me for this explainer.